Hi there, I'm Scott Lowe with ActualTech Media, and thank you for joining us for today's briefing breakdown. Today we're joined by Jesse St. Laurent from Tuono. Jesse, thank you for being here. I'm Scott Lowe with ActualTech Media.
Scott, always good to chat with you.
For today's briefing breakdown. So, Tuono, tell us what Tuono is. Like, what's your elevator pitch when you talk to customers?
Yeah, the short story is managing infrastructure in the public cloud requires cloud automation. Right? There's no way around it. And the cloud automation is hard. Right? That was really the basis for why we started Tuono. Both the codifying your infrastructure, but then also just the entire ecosystem of integrations required to get versioning, rollback, security, role-based access control, secure password storage, all that kind of stuff ends up being a really heavy lift for public cloud. And while that's all fine and good for hyperscalers and those who have software engineering teams that have free cycles to become DevOps teams, what we've seen is there's a huge need to simplify.
So it would seem like in a single cloud world where organizations adopt just but one single cloud, there's challenges, but it may not be insurmountable. Although you make that easier as well. But when you move into a multi-cloud environment, the challenges don't just double; they can double, quadruple, quintuple because of all the differences. How does Tuono help? I mean, at a high level, what does Tuono do to help organizations with both single public cloud providers as well as those who decide to take a multi-cloud approach? What does Tuono do to help them make things easier and more streamlined?
Sure. So there's really two aspects of it. The first is you mentioned with a single cloud provider, you still have to automate that, and now you're either in the world of the console, which isn't practical, right? No one's going to live in that world. So you're in the world of looking at tools like CloudFormation or Terraform or ARM templates. And for anyone who started to look at those, let me just pick a AWS example. You want to put something in the cloud, and question number one, you're an infrastructure architect, you go, all right, how do I connect this thing up? And you're faced with, I either need a egress-only internet gateway, an internet gateway, or a NAT gateway. And before you've even taken your first step, you're stuck going, I don't know which of those things I need. I just want to take my infrastructure and connect it to the internet in Amazon, right? So there's all these complex infrastructure requirements. And if you know infrastructure, you have a subnet, you want to connect it and give it a security policy. So we up-level that to that level, right? I want a subnet, give it a policy, connect it here, done. And we'll worry about putting that policy on the NIC, putting it on the subnet, putting it on the overall connections, putting the firewalls in place. So that's one dimension. The other key is, you mentioned multi-cloud, that same definition will work in both AWS and Azure. So we unify it so that it'll run in either cloud and build functionally equivalent infrastructure, as opposed to having to learn an entire new set of constructs when you change public clouds.
So it would seem that even with a single cloud provider versus a multi-cloud provider, even when you're helping make decisions about what kind of infrastructure needs to be deployed, you're taking an outcomes-based approach rather than what are the inputs, which is kind of makes sense when you really think about it. It's the way things should be. You know what you want the outcome to be, and you're helping people get to that. And at the same time, most of the things that get built in a cloud environment, you're not building just one time. So you can use some of those other tools like you wanted to try to build templates, but if you try to do this stuff by hand, you're going to be repeating this ad nauseum across your entire environment. And you take a lot of that pain away.
You do, and if you want to do it by hand, even if you're just doing something once, the reality is it's going to experience change. So we think about your traditional infrastructure that has long-lived environments, and we'd love to say that those are all gone and the whole world lives in cloud-native 12-factor utopia. But the reality is there's a lot of infrastructure out there that is not this utopia. So that infrastructure, you build it, you might have to add storage to it. You might have to change a rule. You might have to open a port. You might have to close something down. So these things are managed over time. And we help with that because with a declarative blueprint, you can keep applying that. And we just make the changes that are necessary over time to have that up and running. But the other dimension is where you have something that you want to build again and again. Maybe it's development and QA and production, and you spin up 10 dev copies, spin them down. Have a CI environment that automatically spins up and down. Blueprints allow you to do that same thing for infrastructure that wants to repeatedly be built and rebuilt.
There's I was going to pull on a thread that you just mentioned, but it just escaped me. But it'll come back and we can talk about it. But one of the big
Long-lived
challenges,
applications, perhaps, that won't go away.
oh yeah, that was part of it. Actually, um,
I've got a
it'll
question.
come to me. Go ahead,
If I
James.
could ask a question while you think about it. So, um, like a lot of things like this, I think that it starts small and it starts kind of scrappy. And you might do some things that you shouldn't probably do in production. I'm wondering, like in all the environments you see and people that you're helping with this stuff, what are some of the things that people do maybe as they're getting started that are hard to back out of once you get going?
Yeah, I don't know that we have enough time for that list, but I'll give you a couple of the highlights. That is a real problem, right? Which is if you don't codify infrastructure from the beginning, getting back to that is really, really difficult. So, good example. I was working with a user the other day who has a QA environment. And they were having trouble. Now they had 5 QA environments, not a variable number, not that it can spin them up and spin them down by as needed. They had 5, it was fixed. And the problem was 2 of them weren't really working at all. They were being rebuilt. 2 were having problems and 1 was currently working. Now, because they had built those by hand through the console, there was no, oh, you know what, just tear it down and give me a new one button. There was somebody sitting in front of a console doing diffs between all these environments to try and figure out why one worked and the others didn't. That's crazy. And this person was investing actually a small fortune in consultants who were trying to figure this out for him. But in the end of the day, they didn't actually know what that environment needed to look like because there was no documentation of exactly what it was. When you codify it from the beginning, it by definition has documentation of what it looks like. It looks like what the code built. That I would say is the biggest challenge to not starting from the beginning.
So for folks that are watching, the takeaway for me anyway is that if you're lucky enough to be starting from scratch right now, you want to start by codifying everything from the very beginning, because then you're going to have to do the painful thing of recreating this down the road.
The other dimension to that same problem is you say, yeah, well, I'm not going to worry about it in development. We're going to codify it for QA or codify it for production. The problem is, who knows what development looked like? And when you try and duplicate that in production, now suddenly the app doesn't work. You go, well, it's just like development, except it's not, because they weren't built from the same blueprint. So they have different behavior, and now you're debugging why your app doesn't work.
So if you take this approach, it's a really easy way to solve a problem we've had for a long time, which is exactly what you've just described. Like, oh, I don't know, it was fine in test, and it blows up in prod. If they're all built from the same blueprint, it's got to be right in all the environments, right? That's cool. What were you going to say, Scott?
And if
So the other piece of this is, I think you alluded to this earlier, Jesse, but it's easy once an environment's been in production for quite some time, or whatever the environment is, for it to drift from its original baseline. And a lot of the existing tools on the market don't do a great job of helping organizations protect themselves against that drift. What does Tuono do differently from other solutions out there to help organizations control the drift from the approved baseline that they want to have in their blueprints?
Yeah, the system allows you to take what you've built, your blueprint, and compare it against what's actually deployed. And we'll tell you that your running infrastructure no longer matches your source of truth, which is the declarative blueprint. From that, you get back, these things are different, right? This is not a match. The interesting thing is if those were made directly in the console, shame on you to a certain extent. We know we're not supposed to be doing that. But the reality is, it happens every day all over the place, right? People log into the console and fix something because it was broken. But having your cloud automation platform tell you, hey, this doesn't match what I was expecting to see here. You want to codify this so that things don't go sideways on you, is super valuable to prevent that. Because if you don't do that, next time you deploy, you're going to undo that fix that somebody did at 3 a.m. to fix a production app.
One of one of Tuono's big differentiators is also how you handle secrets, right? There's a lot of folks out there that in whatever tool they're using now, they're hard coding passwords, they're hard coding IP addresses, they're hard coding things you really don't want other people to see, and you want things to be easy to change later. You don't want to go through 50 different places and change it. what are you doing to help organizations fix secrets that should be secret rather than, not secret?
Yeah, I mean, there's a lot of secrets managers out there. So this idea isn't new. Right? The most well-known are probably, Amazon has a secret manager, Azure has a key vault, and everybody's heard of HashiCorp Vault, which is a fantastic product for keeping secrets safe. The challenge is, they all have different challenges. One's locked to Amazon, one's locked to Azure, and HashiCorp Vault has the wonderful behavior of when you set it up in development mode, it's super easy. Everything's pretty much wide open. The problem is when you turn it into a secure installation for production and you go on lockdown, that's a very complicated, what you would like to think day, but it's probably weeks or months, because it's trying to be secure. So every error just comes back saying error. Because if it told you error, this key didn't match that key or something useful, then that would make it easier to hack. So it just says error. So what we felt is there had to be a simpler way for folks to go about doing that. So we built right into our platform, fully integrated, nothing to deploy or manage or upgrade or set up. You just point and click or hit the API, drop your secret into the vault. That vault is dedicated to your organization in the Tuono SaaS platform, and you can store as many secrets as you want in there.
So you shared with us before this this interview a short video that we'd like to play, and then along the way, I'd like to ask some questions if you don't mind.
Sure.
All right, let's play the video.
Hi, this is Jesse with Tuono, and today we're going to walk through a demonstration of Tuono's Secrets Manager. The first thing I want to show is a high-level blueprint. And here you can see we define a couple of variables, location, and the other things you would expect in a blueprint that's going to build infrastructure in the public cloud. But what I want to focus on for just a minute is what we see here. And this is where we pass through the information on how this virtual machine is going to be configured.
Derek. Okay, so Jesse, how common is what we see on the screen right now in your experience and what you've seen with people?
Yeah, I would say it happens in almost every account, almost every day, which is, where do you put the password? Where do you put the API key? Where do you document these things? They've got to go somewhere. And James was asking the question earlier, well, do you start in development or do you wait to go to production? Well, it's a development password, not a big deal. We'll just put the password in there. And then this thing just sort of evolves. And the next thing you know, you've got API keys that leaked, you left access open to something. Happens every day. And you can try and obfuscate it. But even when you obfuscate it, it might end up in a log somewhere along the line. Secrets are very complicated to not only make sure they don't appear in plain text there, but make sure your really helpful debugging messages that get dropped into your logs. Did they drop a secret in?
And when you talk about obfuscation, security by obscurity is no good anymore. I mean, it used to be the way to go because it was the only thing you could do. But it's kind of dead, right? Or not something you want to be doing if you can avoid it.
It's not something you want to bet your business on. It's not something you want to bet the security of your customers' information on.
All right, let's continue.
We pass through a username, a password, and a public key. Clearly, a password in plain text is a giant disaster. We never want to see that. And there's a couple ways we can manage that. The first is, clearly we have to get away from this approach. So let's try this. We can put in, instead of doing it that way, we put the password into a variable. In that case, we can go ahead and define the variable. We have admin password, it's a string, and that's where we put our password. If I go look in my environment where I'm going to deploy this, we'll show in a few minutes we're going to deploy this both into AWS and Azure. But first I'll look here. You see, well, I can put my admin password here. The problem with that is, again, I'm just going to be typing, and that information is going to be visible to anyone using the system.
For a second. So Jesse, there's two things we have to protect from when it comes to secrets, right? You have to protect your environment from external discovery of a password that some nefarious actor could use to compromise the environment. But you also, unfortunately, have to protect your environment from internal people, either through that do some damage either through malice or negligence, right? So you're trying to, this is part, you could do what you're talking about with creating variables that may not be as external as putting something right in the code. But you still have internal people. You may not want to actually see that password. Is that an accurate statement?
It is, and really, this is not much different than just putting the password in the code, because at the end of the day, that password still is going to get handed through the entire process of potential logging along the way, all that kind of stuff. And anyone who's managing your environment is going to see it. So you mentioned whether it's malice or accidental. Most of these issues are not malice, right? Most password leaks are not somebody in IT saying, you know what, I'm going to get this company, I'm going to throw this password in a log file. That's just, it's an accident. No one leaves their buckets unprotected because it was intentional. They went, oh, I forgot to make that configuration update. So exposing that to the team, it just gives the opportunity for it to become public information.
Got it. Let's continue.
Again, that's not an acceptable solution. So what Tuono's done is fully integrate secrets management directly into the platform. What this means is there's a much simpler approach. We can go into secrets management. We can create a new secret. In this case, let's call it my password. We'll say that anyone in my organization can use that, and we'll give it a value. So I'm just going to type in a password here, and we'll create that secret. Now that secret has automatically been stored in a vault that's dedicated to my organization. No one else can access it, only my organization. If I go back to my blueprint, what I now want to do is change.
Jesse, where is that vault stored? Is it stored in an on-premises container somewhere? Is it stored in your cloud? Or is it stored in how is it? How do people keep it from?
Yeah, it's behind a whole series of locked environments in the public cloud. So it's under the covers. We're using Hashi's Vault. Right? Vault is great technology. I have nothing bad to say about it in terms of its security. So we leverage it under the covers. The challenge is getting it to work the way you want it to and to be as secure as you'd like it to. So leveraging that, we dynamically build a dedicated vault for every single customer that signs up for our product. So we do that on the fly. When you come into our product, where you load your credentials and you load your secrets, those are stored in that dedicated vault, actually hosted in a public cloud environment in the US.
I have some more questions on that, but let's continue the video and I'll ask them at the end.
That type from string to secret. What that does is it requires anyone using my blueprint to pass that information in as a secret. So my password is now defined as a secret. I reference it here as that secret. And when I come to my environment, I'm able to select from the secret manager the password. Now, I don't see the secret here. I'm not able to read it. I'm not able to change it.
Okay, so when that's deployed, that blueprint is deployed on an environment by environment basis. So if it's deployed to AWS, I choose whatever password I want to use for the AWS resources. When I deploy it to Azure, I choose whatever password from the vault that I want to use for the Azure resources, right?
Correct. And we're talking about a password. A password is just one example. There's all sorts of things you might not want to make public. Some folks I talk to view their public keys for SSH, for example, as being secret information, even though they're called public keys, right? You might want IP addresses not broadcast. There's all sorts of things you might want to pass through that way. But for us, when you build an environment is essentially picking where you want to deploy that blueprint and setting a custom set of variables and secrets. So in this case, you'll see the same blueprint used. We use the same secret, but they could be completely independent secrets deployed into two separate environments, one running in Azure, one running in AWS.
Got it. Okay. Continue.
While we're stopped, I've got a quick question on scaling secrets. So I could see two different avenues. One is where you create lots of secrets where one secret is unique to one blueprint. Seems to me like that could get kind of cumbersome to manage. The other way is, obviously have one secret, use it in lots of blueprints. That's easy to manage, but seems like it might be a bad idea. What is your advice there?
Yeah, I mean, every organization pretty much has a policy for this, and if they don't, they probably should. So, our advice is listen to your policy. Every company should have a password policy, for example. I've worked with organizations who have policies that basically they can't ever reuse passwords anywhere ever, which creates a lot of overhead for them, and they just have to deal with it. I've worked with organizations where, by application, all the servers in that environment have share passwords, or the same thing. A lot of places, I'm demoing with password just because it's simple. We see the same thing for public keys commonly for managing access. It ends up being dictated by organizational security policy. But the thing we bring there also is allowing access to those at the individual organization or coming shortly team level, so you can restrict that as well.
I suppose if it gets to be too much to manage, you could always just make a spreadsheet with all the passwords in it so you can keep them straight, right?
Yeah, perfect solution. And so you can. That's what happens with a lot of these solutions, believe it or not. So there's technology out there where the solution is to use a variable, and you separate the variables out into essentially a variable file, and that file is full of all of the secret information. And you try and keep that someplace safe, like an encrypted bucket in an S3, or there's a whole assortment of scary places those get kept. But at the end of the day, it's a file full of passwords, which is terrifying.
Yeah.
We don't do that.
How is the vault different than that? Like what security mechanisms differentiate the vault from just storing an encrypted file in an S3 bucket? I know that there's a lot, but what at a high level, what's the difference?
So there's a whole series here. The storage it's actually saved on, that the vault is stored on, is encrypted. The information inside the vault is encrypted. And in fact, Vault is, one of the wonderful things about it is incredibly secure. One of the challenges is it's almost like those safes that you see in the movies where if you poke it the wrong way and you break the magic glass panel, you can never open the safe. Getting your data back out of the vault reliably is actually the biggest challenge. So what we've done is we actually link your user when you log into our portal. The security policies associated with your user are actually carried all the way down into the code of the vault. So the groups you belong to, the organization you belong to, your individual information, that actually goes all the way into the vault to give you access. And it's not just Tuono's code that programmatically says, Scott, you don't have rights to access that. Even if you somehow gamed our code, the vault's going to tell you, no go, you don't have the rights to access that.
Let's continue.
From this screen, I can go back to the credential manager and edit it if I want. But from here, all I see is that it's been set to my secret password. So I'm going to apply this into AWS, and I've got an environment here that's using the exact same blueprint, my secrets demo blueprint. It obviously has the same variables because those were pulled in from the blueprint. And this one is going to deploy to Azure. So I'll grab my password here, hit submit, and we'll do an apply on that as well. So now we just switched our passwords to pull automatically from our secure secrets vault. Those get injected and sent to the cloud provider in both AWS and Azure. So from a single blueprint, we're building that infrastructure and passing the secret into the multiple clouds. The thing that makes this incredibly unique for Tuono is what we call late injection or late binding secrets. And if we look at this diagram, this is a flow of how information goes through our system. The secrets management here on the left-hand side, we put our secrets, our password in this case, directly into that vault. Now, once it's there, it's stored securely. The problem that often happens with secrets managers is you pull the secret out and then you hand it off to some system that hands it off to another system to another system. It's susceptible to getting logged or leaked all through the chain. So what we do is we pass that entire secret through the chain by reference. So the secret itself is never exposed through the chain. We have essentially an injection device that sits right at the very end of the process, right where you see this green arrow. So when our cloud execution engine is sending that API call to the public cloud, that's the point that our code grabs the secret out of the secrets manager, drops that secret into the API call being made to the public cloud, and sends it off. When that response comes back, we redact that secret out if it happens to show up in there, do it an error message or a warning or something like that. And then we pass it back to you, the user. That's how Tuono passes all that information securely to the cloud without providing an opportunity for it to leak along the way. Now we're going to do a quick fast forward while AWS and Azure finish building. Now Reply has finished in Azure. That system is built. And if we go look at the build that we did into AWS, that one's finished as well. And we've got 2 successful deployments into 2 different clouds using a single blueprint, pulling secrets out of the Tuono Secrets Manager and passing them securely into the public cloud. Thanks for watching.
That was great. So my other questions that I have, how is this, you said that, if you just go with Vault by itself, it can take weeks to deploy. Why, and how do you avoid that? And I want to get to the other piece, the real differentiator in a second.
Yeah, so the answer to how we avoid that complexity is we've lived it, and we've spent months of engineering cycles building essentially Vault as a service. It's sort of strange, we don't talk about it this way, but customers could use our offering as Vault as a service, right? They could use us as a secrets manager as opposed to a total platform. That's not how our customers tend to deploy with us. They use us to manage infrastructure, but we essentially have a complete Vault as a service offering in our platform. The way we work around that is we've done all that heavy lifting, right? We've automated the deployment of Vault. We've figured out how to configure it. We've actually extended and put back into the upstream project around Vault. We've linked it all the way back into your user authentication so that that's completely secure. That's all heavy lifting you would have to do if you weren't deploying as part of our system. And then on top of that, we've made it just point and click to use, right? Add secret, update secret.
The real differentiator, though, obviously the Vault as a service is critical because you're saving so much time, but it's that little green arrow that you pointed out in your demo, right?
Yeah.
Can you tell us more about that?
Yeah, so one of the classic problems is you pull the secret out of the secret manager. Take Azure, AWS, doesn't matter. You then hand it off to go do something, right? So it goes from system to system in this pipeline. And inevitably, you have devices that are doing logging. You're running through code that might have an error and throw a stack trace. All these things happen that make that secret through that entire, I talk about it as a gauntlet, right? The secret's running this gauntlet, and it has to make it out the other side safely. The key for us is that secret actually doesn't run the gauntlet. What runs the gauntlet is a reference to the secret. And only at that very last instance do you go through a proxy that reaches back to the Vault on your behalf, grabs that secret out using your credential information, puts it into the API call, and makes the API call to the public cloud side. So like I was mentioning earlier, with even if you tried to hack our system or you found a bug in our system where you tried to get into the Vault, Vault's going to reject you. In this case, even if something gets leaked into a log by us or by some other type of error along the way, we do a stack dump because of some error, that secret's not there. Right? The only way to make sure you don't leak a secret is to not have the secret.
Right. So bringing this back to the whole value proposition for Tuono. So passwords change over time too, right? For whatever reason, your password policy may require, you change your passwords every 180 days or whatever, right? Which we all hate, but we have to do, right? But because you're also not just monitoring for drift from an established baseline, but because you're also able to enforce to a point the baseline configuration's been approved, you can basically just redeploy the templates, generally not have to worry about things having changed in production or whatever environment you're deploying into. Is that correct?
Yeah, and if you're using a password and you want to go update that password for builds, you can go into the Vault. or you can go into our interface in our portal, or I say portal, everything we do in the portal can be done through the API. But go into the portal, you can never read a secret. We don't even ever let you read a secret back out. So once it's in, it's in. There's no way to get it back out. However, you can go in and update to use a new password going forward, add that new password in, and then execution moving forward will use that new secret. So you can change your information and continue. You wouldn't even have to change anything about the blueprint. It would already know to use the secret. You change the secret. The reference to the secret is still the same. So from then on, it just uses the new information.
To redeploy the blueprint to any machines that are using the old password to update the password, or is that done somehow, some other way?
Yeah, that would be done some other way. It would be a different workflow. The workflow we saw here is deploying a new instance, putting that password into the instance. It would be a different workflow to update that password in the instance.
Okay, so it's easier than redeploying the blueprint. You have some other mechanism to do that.
Yeah, essentially for any new deployment, you can inject the password at that point. It's a different process to deal with changes.
Got it. Okay. James, what are the questions? I'm sorry, I've been kind of dominating here.
No, that's okay. We're running out of time here, so I think I will ask my last few offline. But I love that, and it's one of those things where, like, after you've said it, we should only inject the password right here at the very end. There's that part of me that's like, well, why did we ever do it any other way? It's one of those very logical things, and I love that. So awesome thinking, and I appreciated the demo.
So to put a bow on this, Jesse, if you had to let the audience know, basically, what are the top 3 things you want them to take away from this discussion with regard to Tuono, with regard to secrets management, or whatever, or just life in general?
My life advice. I don't know that I should drink more coffee. I don't know who said that, but I'm all in favor of that. I just in prep for our session, we had coffee prep before we started.
Nice.
But simplify what you're doing, right? With complexity comes risk and errors. Our whole goal is to make this consumable for anybody, right? You don't have to be trained and be a ninja in the ways of cloud APIs to get up and running and be effective in the cloud. This is a platform that lets you get there, and as a novice, but grow with you over time, such that even when you are an expert, you can still leverage the API and do all the cool tricks you want. But when you're a novice, you can come in, point and click your way to cloud infrastructure in just a couple of minutes. Part of that comes from delivering everything fully integrated. So you're not trying to glue 27 pieces of infrastructure together with your own code. And part of it comes from that we've simplified the code itself so that anyone who can do basic scripting, download something off the internet and make a few edits to script, can build infrastructure and can codify things with blueprints. That's really the key takeaway for us.
Good. Jesse, as always, thank you for joining us for yet another episode of something here with ActualTech Media.
Always good to catch up, Scott.
And thank you to James for participating, and thank you to Derek Holt for his behind-the-scenes efforts. If you want to learn more about Tuono, please visit the link on your screen or follow them at Tuono Inc. on Twitter. Thank you, everybody, for joining us today, and we'll see you on the next Briefing Breakdown.
Thanks, everyone.